Welcome back, fine physics folk, and greetings. I saw that, for the most part, we were able to kind of understand the main concepts that were explained in the first video, the one that I posted on Monday of this week. This video is going to go a little bit further. We understand that we have four main forces, but what if you're not just solving for the net force and the acceleration? What if you're solving for one of the component forces like a friction or the external push or the air resistance in the case of a skydiver? That's what this video is going to go through. Technically, we won't be learning anything new. We will just be applying what we already know to different situations. Let's do it. Okay, so right here, what we have is a review problem, something that we could have done from the first video. 7 kilogram crate. Okay, 7 kilogram crate, 7 kg goes in the crate. Yes. Okay, it's pushed to the right with a force of 40 newtons. Okay, so far so good. And the friction of the floor is 5. So if you're pushing it to the right, we know that friction is going to be left. All right, the reason I am drawing this problem is because oftentimes, many times on people's work that they turned in, this is all they drew for their free body diagram. They neglected two forces. I know that we aren't doing much with the vertical forces yet. I know that they almost always cancel out. However, I need you to get used to drawing them so that when they don't cancel out next week, let's just say when you push things at an angle, you know where they are and where they come from. But for now, I want you to draw the gravity, the 68.6 down and the 68.6 going up. I want to see this. This is what I want to see. This is the free body diagram. So a couple people only were drawing the right and left arrows, and I know that technically that's all you need to draw to get the right answer, but this is what I want to see for a complete answer. So I said the up and down arrows cancel, and they do. They have to be there, but they cancel. And then to get the net force, if I had 40 to the right, 5 left, it would be 35 newtons right. And we know that the mass is 7. And then the acceleration would be 35 divided by 7, which is 5 meters per second squared to the right. So this is just a quick recap of everything we learned in the other video. If you have additional questions, feel free to reference that video or shoot me an email. Let's go learn the new stuff. What is the friction acting on a 12 kilogram crate that is pushed with a force of 83 newtons and accelerates plus 3.5 meters per second squared? All right, well, 12 kilogram goes in the crate. Okay, so far so good. And I cannot forget the up and down arrows. 9.8 times the mass. Please, please, please make sure these get included. Okay. Awesome. So it says, what is the friction acting on a 12 kilogram crate that is pushed with a force of 83 newtons and accelerates plus 3.5 meters per second? Well, what way is this being pushed? Is this being pushed to the right or is this being pushed to the left? Because the acceleration is positive, we know it must be pushed to the right. So that means this is actually to the right. 83. So because it is accelerating positive, we know it's going to the right. Now, okay, we know that the mass is 12. We know that the acceleration is 3.5 positive. So how do we get the net force? The net force is just mass times acceleration. And when I do mass times acceleration, I get a net force of 42 newtons, right? Just FEMA that, multiply that. So I know that the net force is positive 42. Okay. I know the friction has to be going left. This is what we're going to do. We are going to treat this as vectors. We know how to do vectors. We're going to treat the net force as the resultant vector because it technically is. For now, all we're doing is worrying about x vectors. We're not going to look at any y vectors. We're not doing that yet. I just want to show you how this is going to work for now. So our final x vector, because the y's are just going to be 0. Their y's are going to cancel out, so we don't need to worry about them. Our final x vector is going to be positive 42. And if you remember anything about vectors, we have two other horizontal arrows. This x equals 83, and this x equals question mark. So what we're going to do is we're going to write this into equation. Remember, adding the individual vectors has to equal the 42. So I have x plus 83 equals 42. All right? So to get x by itself, I'm going to minus 83 from both sides. And what is 42 minus 83? Negative 41 is the x. Okay, so that means that the friction, this x, is negative 41. Does that mean a negative 41 goes in the picture? Well, no. In fact, we knew it was going to be negative. Look at the picture. The friction arrow is already pointing to the left. Remember, negative means direction. So we could just say that the friction is 41 newtons. So what we did was we recognized that forces work like vectors, and all the vector stuff is going to come back with forces. So what we're going to do today is remember how to use vectors and apply it to free body diagrams. The net force is the resultant vector. That's the key. Net force, resultant vector. And if you really understand what that means, then you are good. If you don't, then pay attention because we're going to do several more examples. What is the external push on a 5 kilogram crate? So 5 kg goes right there. And before I even finish reading the problem, I'm going to go ahead and do 49 and 49. Love it. Great. That experiences 15 newtons of friction and an acceleration of positive 6 meters per second squared. Okay. What way is this going? If it is accelerating positive 6, that means it's going to the right. So if it's going to the right, what way is friction? That means friction is left. Because friction has to be left, it has to oppose the motion. I know that this has to look like this. Okay? I need us to be able to read the problems and interpret the numbers correctly to put as many arrows in as possible. All right, so let's go ahead and get the net force. The net force equals mass times acceleration. The mass is 5, the acceleration is positive 6, so the net force is going to be positive 30 or 30 to the right. Awesome. So we are looking for what the external push is, the applied force. We're looking for that arrow right there. That's what I want to know. So we are going to treat this as vectors. Our resultant vector is the net force. Good. This vector, who knows? Don't know. This vector because it's going left, in the equation, we have to treat it as negative 15. Left means negative. So, okay, this plus this has to equal this. Nice. Negative 15 plus x equals 30. I'm going to add 15 to both sides. X equals 45. So the external push has to be 45. And let's just see if that makes sense. 45 minus 15 is 30. Nice. Everything works out. Everything checks out. We're just going back to vectors. Okay. Now, this is how it can get a little tricky. It's the negatives. It's always going to be the directionality that gets us. So let's go ahead and take a look at this 2 kilogram crate. 2 kg. So we have 19.6 going down. We have 19.6 going up. Equal and opposite. They cancel out. Awesome. It experiences 20 newtons of friction and an acceleration of negative 2 meters per second squared. Okay, if it's accelerating negative 2, it's accelerating to the left. If it's accelerating to the left, that means the friction must be right. So in this case, the friction is right here, to the right. Friction opposes motion. Okay, net force equals, I don't know, but what's the mass? The mass is 2. What's the acceleration? Negative 2. Okay, easy. Mars rover. Good. Good. That's a squared. Okay. Negative 2 times 2 is, negative 4 newtons, or 4 left. It means it's 4 left. Okay. Now, some of you might be able to just intrinsically look at this and know, I know what the answer's got to be. But let's figure it out. So I know that the x has to equal negative 4. We're looking for the push, F of P. This is what we don't know yet. So x equals question mark. And this x equals positive 20. Okay. So what we're going to do is x plus x equals x. X is because these are all horizontal arrows. X plus 20 equals negative 4 minus 20 minus 20. X equals negative 24. Okay, so x equals negative 24. Does that mean the external push is negative 24? The external push is actually just going to be 24 next to that arrow because it's next to a left arrow. So that is the negative. You do not write it as negative 24 on a left arrow. That's redundant. We just know that the left arrow is 4 bigger than the right arrow. That's what we're saying here. And again, add it up. Negative 24 plus 20 is negative 4. Checks out. All good. Good job. Nice. Now this one's just different. It's just different. But let's see if we can figure this out. I'm trying to be a little difficult. Give you a little little tricks and yeah. All right. Well, let's just work it on it. Okay. Here we go. I want to get the net force. Okay. We know that the first thing we have to do is get the net force. Okay. How do we get the net force? Get the net force. Oh, wait, we don't have a mass. Huh. Interesting. Well, I know that the up and down arrows have to equal. I know I was being tricksy here by not showing you them. there are missing values. We assume that there are the 4 arrows. We are assuming that, and we're just filling them in. We're looking for the missing values. I probably should have drawn the blank arrows, but let's assume we have all 4. So if we have the up is 29.4 and the down is 29.4, we always take the mass and multiply it by 9.8 to get this. So we could do the reverse. So what's 29.4 divided by 9.8? Nice. So we know that the mass is 3 kilograms. 29.4 divided by 9.8. We know that the acceleration is positive 4. Okay, so hold on. If the acceleration is positive 4, is the 30 here, is this the friction or the push? It's got to be the friction. The reason we know it's got to be the friction is because if it's going right, the arrow to the left must be the friction. The net force is 12. 3 times 4 is 12. Oh, wrong unit. Sorry, 12 newtons. All right, so in this case, we're looking for the push. We're looking for the push. Okay, so let's do it. We got 12. X equals positive 12. X equals, we don't know. We just don't know. X equals negative 30. Awesome. Let's plug it in. Negative 30 plus X equals 12. Add 30 to both sides. Nice. Gone. X equals 42. So the external push is 42 newtons. Nice. Questions? You can't ask me now, but definitely shoot me an email. Now, the next question, I'm only changing one thing. The next question, I'm only changing one thing. The only thing that's changing is instead of accelerating to the right, now it's accelerating to the left, which means this is no longer the friction. This is now the push. Okay. So we can go ahead and we can get the 3 kg the same way. We can do 29.4 divided by 9.8. All right. So the net force is going to be, this time, the mass is 3 still. That hasn't changed. The acceleration is negative 4. Negative 4 times 3 is negative 12. So the net force is negative 12. So your resultant vector is negative 12. And this time we're looking for the friction. So we know that this number is going to be smaller than this number. Bizzuto, I didn't know that. Well, let's think about it. The friction's always got to be smaller than the push, otherwise it's not moving. So negative 30, x equals, I don't know, question mark. Negative 30 plus what equals negative 12? I don't know how to do this. Let's find out. Negative 30 plus x equals negative 12. We're going to add 30 to both sides. What is negative 12 plus 30? X equals 18. In this case, the friction is 18. Positive. Nice. The only difference between these two problems was the way it was going, but that affected the arrows significantly. I want to make sure you understand how all these variables connect. It's all about vectors. Okay, skydivers, yes. All right, so this is the basic skydiver. What is the acceleration? We know how to do this. Skydivers, the mass goes in the head, 60 kg. The down arrow is gravity. The up arrow is air resistance. So the air resistance is 300. The down arrow is going to be 60 times 9.8, 588. I don't know why I stuck that in. Awesome. So, just like we did before, these are the old problems. But think about it in terms of vectors. Instead of adding the x-axes, now we're adding y-axes. Up is positive, down is negative. So let's think about it. What's the net force? 588 minus 300. Well, actually, think about it like this. The net force would be positive 300, because that's going up. Up is the positive direction, plus, here the y is positive 300. Here, the y is negative 588. Sorry, my mouse was, there it is. And there it is. There, oh, that's better. So now we're still using vectors. We add up the component vectors to get the resultant. So the negative 588, and that's where we get the negative 288. Many people in the skydiving problems on the homework that was due yesterday said that the net force for skydivers was positive. And I want to be very clear. The net force for skydivers must be negative. The reason the net force must be negative is because they're going down. Gravity is pulling them down. And down is a negative direction, which means your acceleration would be negative. If you had a positive acceleration while skydiving, unless your parachute was open, and there was one problem where like the parachute would be open. I was hoping that was going to kind of kick some people to remember, oh wait, now being positive or negative matters, but now you just FEMA that to get the acceleration. So this is how the skydiving problems have been done. But let's think about it in terms of vectors. Because what if, just what if, you're looking for the air resistance? Now let's think about it. We have gravity and we have air resistance. These are two y vectors. Let's ignore the x for now. Let's just talk about the y vectors. They are going to add up, and they are going to equal the net force. Okay, let's see what we can do. First things first, I'm putting the mass in the head. 50 kilograms goes right there. Okay, so that means 50 here. Okay, acceleration is 3 down, or -3. Okay, which means that the net force is negative 150. Okay, so when I add the two individual y vectors, it has to equal negative 150. Well, how do I get the down arrow? The down arrow is always mass times gravity. The down arrow is always the mass of 50 times gravity, which is 9.8. So we're going to get 490 going down. I'm going to say the y, because it's down, it's negative. Okay. I don't know what the air resistance is. I'm looking for it. But I know that this plus this equals this, just like vectors. The net force is still the resultant vector, and these are our only two. So let's see what we got. So I have negative 490, plus y equals negative 150. All right, so what I'm going to do is I'm going to add 490 to both sides. I'm just running out of space. But all I know is just understand that I did negative 150 plus 490. I have y equals the air resistance. It's a positive. Mathematically, it's positive, so it needs to be an up arrow. We already knew that, though. But this is what you do. You treat it like vectors. You add them up, and then the net force is always the resultant vector. This is how you solve for the missing arrows. So, your homework is the even more friction practice. I apologize. Let me just apologize. I posted both assignments for this week on the same day. And some people started with this one and got really confused because they didn't do the basic one first. If you tried the even more friction practice and just got frustrated and said, I can't do this, give it another look. See if you can do it. You will eventually have to learn it. It's worth it. With this presentation and the one that we did earlier this week, you should be able to do both assignments. Next week, I will not post both assignments up. That created way too much confusion, and I think people were unnecessarily frustrated. And for that, I apologize. But moving forward, assignments will only be posted one at a time during the week. Complete that assignment and you're good. This is due tomorrow night at 11:59 p.m. and I will respond to all your questions. Good luck.